In this video, I am going to discuss the numerical problem based on capacitor. But before I start this, first, once again, I would like to remind you, in series combination, as you know, in series combination of the capacitor, equivalent capacitance 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus so on. So in this way, first you will find out what is the value of 1 upon C equivalent, and then you will calculate what is the C equivalent. And in parallel combination, in parallel, as you know the formula, C equivalent is equal to C1 plus C2 plus C3 plus dot dot dot, this one. One more thing I would like to remind you here. In series combination, this one is 1 upon C equivalent, this one. But your aim is to find finally C equivalent. So first you will find out what is the value of 1 upon C equivalent, and then you will calculate what is the C equivalent by using this formula. Again, in series combination, if there are only two capacitors, in series combination, in series, if there are only two capacitors, then you can write 1 upon C equivalent, suppose 1 upon C1 plus 1 upon C2. But here I am telling for two only. This one is C1, C2, and this one is what here? You can write C2 plus C1, or simply you can say 1 upon C equivalent is equal to C2 plus C1, or C1 plus C2 upon C1, C2. So C equivalent is equal to C1, C2 upon C1 plus C2, or C2 plus C1. I would like to tell you only this one. If two capacitors are joined in series, only two, then their equivalent can be calculated directly by taking the product of their capacitance in numerator upon sum of their capacitance in denominator. And dear student, always remember this, C1 and C2 always given in the proper unit. When you will solve the numerical problem, then you will find out that their C1, C2 means capacitance is given either farad or microfarad or nanofarad. So remember this, finally you will write the answer of C equivalent in the proper unit. Now, like this first case, if these capacitor, this one between AB 8 microfarad, and here also across MN 8 microfarad, and across ED 8 microfarad and 8 microfarad, two capacitors are joined. Our aim is to find the equivalent capacitance between M and N. So first you look here, out of all these capacitors which are joined, your aim is to find the equivalent capacitance between M and N. M and N. So for this M and N, it is clear from this one, this 8 microfarad, this 8 microfarad, both are in parallel. But this 8 microfarad and this 8 microfarad both are in series. So first you will find out equivalent capacitance of these two 8 microfarad and 8 microfarad capacitor. And their equivalent you can find C equivalent. I am taking the equivalent capacitance of 8 microfarad which are connected across ED. This 8 into 8 upon 8 plus 8. For two capacitor, you know equivalent capacitance C1, C2 upon C1 plus C2. So simply this one is 64 upon 16. So 64 upon 16 is equal to 4 microfarad. It means at the place of these two capacitor, 8 microfarad and 8 microfarad, we can put a single capacitor of the 4 microfarad. So simply in the next one you can say, at the place of these two capacitor, you can put a single capacitor of 4 microfarad. And now you can see here across Mn 8 microfarad, 8 microfarad and 4 microfarad. These three capacitors are joined in series parallel. So they are equivalent C equivalent across Mn. So we can write here simply C equivalent is equal to 8 microfarad plus 8 microfarad plus 4 microfarad, and simply you can say this one is 20 microfarad. It means the equivalent capacitance of this combination of the capacitor across Mn is 20 microfarad. Take one more example, like here across P and Q. 4 capacitor of capacitance 1 microfarad are joined like this one here. It looks 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad. Here it looks that all these are connected in parallel, but between PQ all these capacitors are joined in series. You know what is the condition for the series combination of the capacitor? One plate of first capacitor means second plate of the first capacitor be connected to the first plate of the second capacitor, and then second plate of the second capacitor be connected to the first plate of the third capacitor, and so on. And now you see here this first plate of this first capacitor is connected to the point P. Second plate of the first capacitor is connected to first plate of the second capacitor. Second plate of the second capacitor is connected to first plate of the third capacitor. Again the second plate of this one be connected to the first plate of the next capacitor, and in this way you can say all these capacitors are joined in series and their equivalent 1 upon C equivalent is equal to 1 upon 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 1. Simply you can say 1 upon C1, 1 upon C2. It means 1 upon C equivalent is equal to, simply you can say here 4 by 1, or C equivalent is equal to 1 by 4 microfarad. Or you can say if all these capacitors are joined in series like this one here across P and Q, then their equivalent is given by 1 upon C equivalent 1 by 1 plus 1 by 1 plus 1 by 1. Simply 1 upon C equivalent by 4 by 1, so C equivalent is equal to 1 by 4 microfarad. Please don't forget to write the proper unit. Unit must be there. And in the board exam, without unit, the examiner will never give the marks. So please always you will write the proper unit in final result. Second case, if between PQ 3 capacitors C1, C2, C3 are joined like this here, C1, C2, C3, and this one is connecting wire simply here. And our aim is to find the equivalent capacitance between PQ. Already I have told you in the previous video, in the parallel combination of the capacitor, one plate of each capacitor be connected to one point, and second plate of each capacitor is connected to the other point. Even when you will look the figure, then here simply maybe this will also come in your mind, all these three are in series, but actually these three are not in series. First you see, is it fulfill the condition of parallel or not. So one plate of each capacitor, you see here, one plate of C1 means this plate of C1 is connected to this point. One plate, this plate of the C1 is connected to this point. This plate of C2 is also connected to this point. And this plate of C3, through this wire, it's also connected to this point here. It means this plate, and this plate of the capacitor C1, C2 and C3 be connected to this point here through this wire. And now you see here, next plate means other plate of the capacitor C1, C2, C3 is connected where? So now you see here, this plate of C2 is connected to, this plate is connected to this point. this plate of C3 is connected to this point. This plate of C3 is connected to this point, and this plate of C1 is connected through this wire also at this point. It means it fulfills the condition of parallel combination of the capacitor, where one plate of each capacitor be connected to one point and other plate is connected to the other point between P and Q. And in this way you can say the C1, C2 and C3 are joined in parallel between P and Q, and the equivalent capacitance between PQ, the C equivalent, simply you can write this is equal to C1 plus C2 plus C3, and in this way we can find the equivalent capacitance between P and Q. Suppose in the same diagram, if one more capacitor is given, suppose here C4, suppose one more capacitor is given here C4, like this one, and here given PQ. And now in this case, the equivalent capacitance, how can we find? So for this case, first you will find out the equivalent capacitance of these three, and at the place of these three capacitor, you can put a single capacitor of C equivalent, means C1, C2 plus C3. Equivalent of this one, you can put a single capacitor at the place of these three, and there simply you can write, in this case, this one is C equivalent, and with this C equivalent, this C4 is connected in series. And now you can say here between PQ, now equivalent capacitance of these two. Now you see here what is the equivalent value of this one, which already you have calculated here. This one and this one both are in series. Again you will apply the equivalent capacitance for finding in the series combination, and then you can find the C equivalent dash between PQ. And in this way you can solve the problem based like this one in the combination of the capacitor.